Well, good afternoon. And thank you for coming to a research talk on the final afternoon of the conference. I hope you guys have had a good time, learned a lot at the talks. This one's going to be a bit different from the others because this is giving you some background on one of the ways that we approach problems in Tableau Research. So this is about how we're thinking about the next class of problems coming up. Some of what I'm going to show you is stuff we've built in the past, some is things that we're building now, and some is stuff we may never do or things we're investigating now that might lead to something interesting in the future. I am Scott Sherman. I'm a principal software engineer at Tableau. I've worked on a lot of features at Tableau over the years, and now I'm part of research. So now, in the past it was about building features that people are using. Now it's more about thinking about what's next. And one of the ways that I like to think about problems is in terms of a language. Thinking about your interactions with tools in terms of languages gives you kind of an interesting lens of thinking of problems. So I'm going to start out with why languages? Why is this an interesting way to think about problems? So how many people know what VizQL is? A few people. So it stands for Visual Query Language, and it's basically the heart of Tableau. It's the whole model for how Tableau works, how you interact with it, how it gets data from the database, and I'll go into more details on that. And I'll also give a few case studies, a few other examples. Enhance Show Me is an internal project, a term we're using for how we're approaching natural language interaction. The Tableau Runtime is an example of how we're using a language for computation to help us with a whole new class of optimizations to make Tableau faster, more interactive. And then I'll also give a couple other examples outside of Tableau, like CompassQL, which is a language for doing recommendations on visualizations. And at any time, if you have any questions, feel free to ask. We're a small crowd, so feel free to speak up if you want. So first off, when you think of a language, the first thing you think of is English, what I'm speaking in now, or Swahili, or Inupiaq. So my son and I played this adventure game that was entirely done in Inupiaq, which is a language of native to northern Alaska, northern Canada, and the Arctic. And one of the things that was cool about it was that it was narrated by native Inupiaq speakers. And a lot of it, of course, was also in English, but they did a fair amount of it in Inupiaq. And it helped kind of put your mind in a different place, in a different culture. And it was one of the things that was fun about it, but it also just gave me an interesting perspective on how even human languages can put you in a different place. Of course, in this community, you think a lot about visual languages. Did anybody see Georgia doing her talk this morning? She gave one around 10. Yeah. So what she was talking about there was about different visual languages. And so one of the things that was cool about it was she spends a lot of time thinking about new ways to build visual languages to communicate something new. And so I found that very interesting. But there are lots of visual languages you can think of. One is musical notation. So I played clarinet in school, and so when I look at that, there's a lot of information captured in there. How notes are going up and down, how short or long they are, how loudly you play it, how slow or fast you play it. There's a lot captured there, but it's also something where I can see that and I know the fingerings immediately. I know how to play that music. Whereas if it were written out in English, it would take me a long time to turn that into how I'm actually going to play that. So musical notation is something that really effectively captures information. Someone who's well-trained in music just looks at that and they can even hear the tune just by looking at that. How many people know Feynman diagrams? One quantum physicist, great. Richard Feynman came up with this notation for describing the interactions between quantum particles. And before this notation, physicists used math equations to capture this information, but they were really hard to work with. They were hard to solve. You really couldn't get much insight from them. It was a lot of work to get any information out of them. And once he came up with that diagram, then it was a lot more obvious how these particles were interacting, and they could make a lot of insights just from this new visual notation. Or something that's perhaps a little closer to the heart of people who work with Tableau, they're Gantt charts, which are about showing how long things take, how things are sequenced, what depends on what. And again, it's a visual language that really conveys a lot more information much more quickly than if you had it written out in English. Then let's shift over a little bit to thinking about computer languages. You've got languages like Python or JavaScript. These are general purpose programming language where you can tell the computer to do whatever you want it to do. Then you have a language like PostScript, which is aimed at a slightly narrower set of problems. It's about layout. It's about describing a document in graphic detail, literally, about fonts, how big they are, exactly their position, so that you can capture exactly what this document looks like, so you can display it on a screen, so you can print it, whatever else. Which then leads me over to domain-specific languages, languages that are much more targeted at solving just one problem. Is anybody here familiar with regex, a programmer or two? Regular expressions. This is all about pattern matching in strings of text. Solves one problem. You wouldn't write Tableau in it, but is really good at finding patterns in strings. And you can express these patterns far more succinctly than if you describe them in Python or JavaScript. Then you have languages like HTML, CSS, languages of the web. HTML, hypertext markup language, is kind of like PostScript. It's for describing documents, but it describes them in a very different way. When you work in HTML, you're saying, this is a header, this is a paragraph of text, this is an unordered list. But you're not saying anything more than that. You're not saying anything about how those things are going to be displayed. The browser has a default way that it displays that. Okay, header is going to be this particular size and this font face. Unordered list, I'll put little dots next to the bulleted list. And then you've got CSS, cascading style sheets, that if you want to be more precise about how it's all styled, you put that in the CSS. So you've got these three languages of HTML, CSS, and JavaScript that all go together to make the modern web. The structure of the document is in HTML, the styling is in CSS, and then all the other stuff that doesn't fit in those two to make all that interactivity goes into JavaScript. And so by having these different domain-specific languages that are all specialized to one area of the problem, it actually makes the whole problem a lot easier. So like, some people can just entirely write in HTML, and that's all they ever even need. And then you have these other languages when you want to change the behavior of one aspect of it. Or something that's a little closer to home in Tableau, you've got TableCalcs, calculated fields. This language is all about, you've got a single row of data, and while you've got multiple columns, you're just looking at one row at a time, and each of those values has a name, the name of the column, the field. And the TableCalc is all about modifying, reshaping that data to produce a new value with a new name to generate a new column. And now you can answer some new questions with your data. But TableCalcs are just aimed at that one problem of reshaping your data in one row at a time. Okay, so it gave a lot of examples of languages, but what I was describing earlier was this is one of the tools that we use for reasoning about problems. It's one of the things that we reach for at Tableau when we're thinking about how we want to solve something new. It's a tool for reasoning. One example of the sort of reasoning that this allows us to do is it allows us to reason about the program itself, which allows us to do a new class of optimizations. So if you're familiar with SQL, structured query language, that's how you can ask questions of a relational database. And by having that query described in SQL, it allows the database to do some optimizations on top of it. Oh, well, look, they want to do a filter and a join, and I could put those in any order, but if I filter this out before I do that more complex join, then it'll be faster. So by being able to reason about the SQL, reason about that language, they can apply a whole new class of optimizations that you couldn't do if you just wrote it out in code. There's lots of other things that you can do as well. There's ways you can reason about natural language, which the team working on the natural language input for Tableau is taking advantage of. Machine learning has an extra layer of abstraction that it can use when it's trying to reason about things. There's a programming language called Agda, where when you write in that language, you are also proving that the code really does what you want it to do, which most code you write, if you've ever done any programming, you know the chance that you got that program exactly right is a challenge in itself. So having a language that is doing proofs as you're writing in it is really interesting. And then I gave you the example of optimizations. It also allows you to map between different concepts. And I'll touch on this more with VizQL. But you've got these different domains. So like with HTML, CSS, and JavaScript, you've got the different domains of describing the document, describing the styling, describing the interactions. Here's another set of domains thinking about the user interface, how things are laid out on the screen, how you query the database, what the visualizations look like. And with a well-designed language, you could tie together these completely unrelated concepts. It also can make it easier to author new ideas when it's aimed at your domain, rather than it being something that's more general purpose. It can allow you to understand new concepts, compose concepts together in new ways. So let's look at a few examples in the Tableau world to kind of ground this in things that probably most of you are familiar with. So here's the calculated field dialog box in Tableau. And this is all about manipulating the information in a single row. So role, there in the upper left corner, that's the name of the new value that I'm going to create in this row. And when it says full name, that's the name of one of the values in the row that already exists. And if that full name is Henry, Jane, or Michelle, then I'm going to create a new value of lead. If it's Susan, Laura, or Adam, I'm going to create a new value of IC, individual contributor. And so now I've created some new data of whether these people are leads or an individual contributor, and now this is new data that I can use to work with in Tableau. And so this is an example of string manipulations, but there's lots of other sorts of manipulations you can do as well. TableCalcs. How many people are comfortable with using TableCalcs in Tableau? Good, that's a good number. So up until recently, I don't remember when we added the feature that shows those numbers, 2, 3, 4, 5, you authored TableCalcs in a dialog box. And it was always a challenge because you just had this text of what it was going to do. TableCalcs are modeled after SQL windowing functions, and whereas calculated fields are about doing a computation in a single row, TableCalcs are about comparing two or more rows together. And so it's about scanning through your tables, but you can scan in different ways. So in Tableau, when you can make multiple panes, and you could scan across within a pane, you could scan across a pane. And so being able to visualize how we're doing these computation across rows was difficult when all you were doing was looking at a dialog box. But since this language had a natural mapping to the visualizations that we were creating, we're a visualization tool after all, we added a new feature, I think it was last year, that has these numbers. And so what you can see here is you've got categories, furniture and office supplies going from top to bottom. We've got ship date going across. And those numbers, 2, 3, 4, 5, are showing you how it's doing its comparisons. So there's no bar at the beginning because there's nothing to compare it to. And then the next one, 2, that's comparing that value to the previous one, and then 3 being compared to 2. And if you look at the grayed out values below it, it also says 2, 3, 4, 5. And so what you're seeing is that it's doing its scans across, and it's not doing its scans down. And so now that you have that extra visual information that goes along with information in the dialog box, it's much easier to understand what that TableCalc is doing. And so the fact that we had this strong language that mapped well to visual components made it natural to add that extra information into the visualization. Another language is something we call Tableau Markup. And if you work with the titles and captions and tooltips in a visualization or with text objects in a dashboard, you might have seen this language. This gives you the ability to pull information out of the database when it was last updated, for example, information about the page you're on, the worksheet you're on, the user's name, fields, and information about the fields. It gives a common language that we can use in multiple places in Tableau to describe extra information that you want to have displayed in the worksheet or dashboard. Okay, so now we get to, like I said, the heart of Tableau, VizQL. And you can basically think of it as what's on the shelves. When you grab a field from the data window, you drag it onto one of the shelves, you are creating a VizQL expression. So rows and columns and filters and the marked card, all that, that's just VizQL. When we're working on it in the code, we look at what we call the visual specification. And it consists of several different pieces. One has to do with layout, and that's what's on columns and rows and pages. Another piece we call the view specification, or view spec, and that's how we're filtering and sorting the data. And finally, the pane specification is all about how we break things down, the level of detail, how we encode things, color, size, shape. And you can have multiple pane specs. So if you take more than one measure and put it on rows or on columns, then on the marks card you have the ability to change those encodings per pane. So you can actually have multiple pane specs, and you can have, in the same visualization, it can have it broken down by color in different ways, for example. This is what it might look like if you just wrote it out. In this case, I said that I want month of date on column, sum of sales on row. I want it colored by product, and I want to exclude desks and chairs, and out comes this visualization here. So that short description in VizQL produces that visualization. Okay, so great. You know, you've seen that before. You're comfortable with that in Tableau if you've used it for very long. But why is this interesting? Where can we go from here? Well, first off is that it maps very directly to the user interface, the UI. So what I showed you there was that VizQL and the shelves, like, it's just a one-to-one correspondence. But it also hides queries. So how many people are familiar with SQL? Pretty much everybody. How many people are familiar with MDX? Okay, one person. So SQL is how we query relational databases. MDX is the language for querying what's called cubes, or hierarchical data sources. And the basic idea behind that sort of data source is that things are pre-aggregated for speed. MDX is a different language than SQL, but you don't care about that because we hide that behind VizQL. VizQL tells us exactly the level of detail we need, how things are filtered and sorted, so that we can figure out how to query the database. And in fact, we actually go a little bit further because while databases say they support SQL, well, every database supports a different flavor of SQL. If you've had to handwrite SQL, you've seen that a lot. And again, when you go through Tableau, you don't care about that because we hide that from you. We can fill in all those missing details. If Access doesn't support count distinct, you generally don't care about that. So VizQL is also describing how we build up queries. It also describes how we lay out the visualizations. It's a very direct correspondence to saying, well, I want this on rows. That means it's going to be broken down vertically. I put this on columns, it's going to be broken down horizontally, and I want it colored, so it's going to break out the marks and assign different colors to them. So VizQL is tying together these three very different concepts in a way that you don't really have to think about it, but it maps naturally to the UI and the layout, and then there's a little more work to building up the query, but that's the most complex part to understand anyway, and so it can just hide that from you. And so we would get a lot if we just got this out of it, but we can do a lot more with it as well. Another example of how we leverage it as a language is show me. Here you can just pick a list of fields and out comes a VizQL expression. So in this example, I have picked ship date, category, sales, and then I went over to the show me palette, and you can see different vizzes have been highlighted. Some have been grayed out. The ones that are grayed out are ones that don't make sense. So for example, the maps are grayed out because I didn't pick a location, and those wouldn't make any sense. There's also a red box around one of them. That's the one that, based on visual best practices, we most highly recommend. So I've picked ship date, which is a time. Time works well when you display it with lines because it connects those times together, shows trend, shows that time is passing, basically. Whereas if I hadn't picked a date, if I had picked just category instead, without a date, well, you don't want to have a line drawn between furniture and office supplies and staplers because they're not connected. It gives you false information. It makes you think that there's some sort of trend or connection there when there's not. So we can have those visual best practices applied because we understand details about the fields that you've picked and we know visual best practices. So this is another way in which we leverage the power of VizQL being a language. So how many people thought that the demo of the natural language input looked interesting? Right? Might be something fun to try when it's available. So I've been working with the team who's doing that, and the first thing that they saw was, okay, well, we can figure out what fields based on what the people want to type, and show me already encapsulates best practices, so let's just use show me. And as long as, so like what I was just describing, that it already knows, oh, well, this is time, therefore I should use lines, otherwise I should use bars. That's exactly the sort of thing we want to leverage from natural language. And as long as that's all you type in, that's perfect. But of course, you can type in a lot more information than just a list of fields. It's one of the powers of having natural language input. So you might, for example, say, show me the average of sales, or the median sales. And that's not something that you can choose in the data window with show me. All you can pick is sales. You would then, after you've used show me, sales is up there, and now you can go change it and do average or mean or whatever else you want. But that also would mean that you couldn't say, well, I want to see the average of sales versus the median sales, because you can't pick sales twice. So show me actually can't help you there at all. You also might say, well, I want to see the trend of this over time. I want to see the correlation between these two things. And so that's additional information that, again, the current show me doesn't have that you would want to take advantage of for natural language input. So we're working on a project that what we're calling it is enhanced show me. It's basically show me, but it's taking additional user intent into account when it's determining the best viz to display. So for example, here, what we've extracted out of what the user typed was that we wanted to see the average of sales and the correlation of that with the average of profit broken down by city. So this is a little bit of additional information that we wouldn't have through show me, and out comes that viz right there. So this is just an example of how we're trying to enhance show me a little bit to give you more power and leverage it from natural language. So this is what it looks like now. You've got the natural language code that is inferring user intent. And it writes to this intent language, kind of showed you an example on the previous slide, runs through enhanced show me, ESM there, To apply visual best practices, it produces VizQL. VizQL takes care of tying together the UI and the query and layout. But being in research, when I look at that, I see a lot of potential for other things that we could do. And so this is the part of the talk where I talk about some of the things that we are looking at. Maybe we'll do, maybe we won't do them. But I see these nice languages, these nice lines, and I see all sorts of other things that could be plugged in here. So, for example, we're also looking at machine learning. So machine learning is all about automated finding of patterns in data that then can produce something. Well, this intent language seems like the kind of level that it could produce. This machine learning algorithm might decide that, oh, well, the correlation between the average and median of sales is interesting, and so that's all it needs to decide on. That information is interesting, write it out to the intent language, run it through enhance show me, and out comes VizQL. Maybe we'll build some interesting UI where we'll give you the ability to specify more of that intent that we get from natural language. I don't know. But for me, I just see a lot of potential for other ways that we could leverage this in the same way that we built Show Me and we were able to leverage that from natural language. I also see possibilities on the other side. So what I described in that intent language, there wasn't anything VizQL specific in there. It was just about fields and some additional user intent. Well, what else could we have come out of that? Maybe we display some network diagrams. Maybe we display Sankey diagrams. I don't know, something that Tableau doesn't support very well right now. So for me, when I see this, I just see all the potential for other things that we could do with this. Okay, to shift gears to another one of our internal projects. This is one actually I started a few years ago. We call the Tableau Runtime. And part of the runtime is a language for computation. So you can use it to describe how we do TableCalcs, how we partition things into pane, how we lay out the vizzes, how we do highlighting, everything that it takes to turn VizQL into an interactive viz other than querying the database, you can describe with the language in Tableau Runtime. And in the same way that I described how SQL gives us the ability to do extra optimizations, the runtime does as well. Part of it is that we can reason globally. So we can now look at all the computations necessary to create this viz. We can figure out what things can be done in parallel, what things should be done in a different order so we can speed things up. There's just lots of ways that we can make things faster as a result. We can figure out whether the work should be done server-side or client-side. So if it's large, complex data, we push that work to the server that can handle it. If it's simpler, smaller data, maybe we push that up to the browser, and now you can get a lot better fast interactivity in the browser rather than having to do round trips to the server. It gives us the ability to cache information so that we can serve it up faster, and it gives us the ability to do incremental updates. So you don't need to look closely at what the details of this are. This is just an example of what the data flow might look like. So this is a dashboard that has a legend. It has a couple zones in the dashboard. It has a visualization. And those purple ovals represent data. The red diamonds represent data transformation. So we have data flowing in from the left and new data coming out the right. And eventually it flows to everything on the right, which is, now it's just going to display it on the screen. But the important thing about this is to think about how you could just do a small, quick update. So let's say that all we change is that data. So some of the other data might be how things are styled, what the dashboard layout looks like, the query results, whatever else. That data, maybe that just represents that you decided that Louisiana was going to be green instead of purple. So all you changed was a color encoding. From this, We know that color encoding impacts the legend, and it impacts how the marks get displayed on the screen. So all those other computations that we did before, we know we don't need to do them again. We can just reuse them. And this might sound like a minor thing, but if you have ever coded in a complex system, you have two approaches for trying to get performance out of it. One is you can hand code all the special cases. Oh, well, I know that if just the color changed, then I just need to redo this, and I redo this, and redo that. And if just this changed, then I'll just redo this. And it turns out that trying to do those sorts of hand optimizations is very fragile. It's really easy to break them because you have so many special cases. Sure, that works when all you're doing is changing color, but when you've got all these other things that might change and they might all interact, the special cases just get really fragile. So the other approach you can take is, okay, well, anything changed, we'll just do a complete do-over. We'll start all the work over again. And that's generally the approach that Tableau has taken. We try to make everything faster because we'll get benefit for that all the time. But it also means that the code is less fragile. But the drawback is that sometimes we do too much work. The nice thing about this is it gives us the ability to have the framework handle the optimization in an optimal way. So now we know we can reason about it and figure out that this is all the work we need to redo, and we know that we'll get it right every time. So we've also done, Tableau Research has worked with the University of Washington Interactive Data Lab and done a lot of collaborations. They happen to be just a couple miles away, which is very convenient. We also get a fair number of interns from the UW, which is really nice. So this was a collaboration from a couple years ago that was all about doing recommendations. So it's about looking at data, trying to figure out what's interesting about it, and recommending visualizations that are most appropriate for that data. What they built on top of is they have a language called VegaLite, which is actually inspired by VizQL. It's very similar, but it's open source, so you can go use it. VegaLite looks a lot like the VizQL that I just showed you, and so it's a simple way to describe what the visualization is going to look like. And so they built on top of that to build this recommendation system. And the basic idea is that they have this specification language that allows them to query over the space of visualizations. And what that means is they've got the ability to specify constraints on how they enumerate the possibilities, and then they've got methods for choosing, ranking, and grouping those recommended visualizations. And so the cool thing about the approach for how they did this was that they used several different languages, all aimed at solving different subsets of the problem, and it allowed them to reason about it and build a really cool visualization recommendation system. And in fact, Anushka, who was involved in that, went on to start the recommendations team for the Tableau recommendations feature. And if you went to Iron Viz yesterday, you saw Jock in his bow tie and his blue suit. So I've always liked this quote. I would have written a shorter letter, but I did not have the time. There's also a quote, I think it was from Woodrow Wilson, where he was asked how long it would take him to prepare for a talk. And he said, well, if I have to speak for 10 minutes, it'll take me 2 weeks. If I can talk for half an hour, it'll only take me a week. But if I have unlimited time to talk, I can do that now. One of the challenges can be figuring out how to express something succinctly, how to get to the core message quickly. And so there was this really interesting project from a few years ago called STEPS that Alan Kay led. A lot of very interesting people were involved in this project. And they had an interesting proposal. So they were looking at software and how much code it takes to write typical software. A complex program like Tableau is millions of lines of code. So I don't know about you, but I can't keep millions of lines of code in my head. That is really complex. And most of the software you use falls in that class. And something like like Windows or Mac OS is probably tens of millions or hundreds of millions of lines of code. And so what they tried to do in steps is they had this goal. It was a 5-year project, and they wanted to just have produced this team of people in 5 years. All they wanted to do was write 20,000 lines of code. However, what they wanted that 20,000 lines of code to do was pretty much everything. So they wanted to write a word processor and a spreadsheet and a browser and a whole UI framework and graphics and sound and the OS all the way down to the hardware level. And they wanted to do all of that in 20,000 lines of code, which if you're a programmer, that sounds like a just completely ridiculous thing. Like there's just no way you could do that much stuff in 20,000 lines of code. So what they did, they just took a very different approach to writing software. They spent a long time looking at each of the problem domains. And within a problem domain, they try to figure out, well, what do we really need to solve in that domain? And then they would pull out of that what they called the kernel, which was kind of the basic description of how do we solve this problem? What sorts of terminology, what phrases in this new language would I want to really be able to express the concepts in this domain well? And then they would create a language to implement exactly what they needed for those kernels. And so one of the things that they needed to do was create a bunch of tools to make it really easy to create domain-specific languages. And so they wrote a whole bunch of different languages in order to accomplish this. And the impressive thing is they did. Going into it, they thought, oh, well, you know, if we have to run this on a supercomputer because the abstractions will be so slow and clunky, like that's okay. We just want to see if this will work. And then they found out that they could actually get enough performance from the way that they were approaching it. In fact, sometimes the performance came out of it because the languages were so well tailored to their domains that they were actually able to do it. Now, the word processor that they produced didn't have all the features of Word, of course. And I can't really imagine, like even taking this approach, how much code you would need for Tableau because we do so many different things now. But still, it's really interesting that they could do all that from top to bottom, from the hardware level through the OS to frameworks to end-user applications, all in 20,000 lines of code. And so I find that really intriguing, and it really shows some of the power of, if you're thinking in terms of a language that's really geared toward a specific domain, you can do some really powerful stuff with it. So I hope I've given you a bit of insight into how we're thinking about problems in Tableau Research and why a language is an interesting way to think about problems. There really are tools for reasoning. When you think of something in a tool that's really, a language that's really aimed at that domain, you can do lots of things. It gives you the ability to reason about the program as a whole. It allows you to map between different concepts. Like, it's one of the things that still gets me about VizQL is how natural it is to have the UI and the layout, like they're the same thing, and it's very powerful. And then that it hides having to write SQL, which I never wanted to do anyway. Like just having all those things come together is very powerful. And that then when you do have those ideas, then it allows you it can make it a lot easier to author things, understand the ideas, and compose concepts together. So at this point, any of the, I've done this one twice. And at this point, the related ones you would just have to catch recorded if you want to watch them. These were a couple talks given by the natural language team on some of the approaches that they're taking. And I think they're going to have all the sessions recorded by late next week, I think is the goal. So you'll be able to watch these online if you would like. And then, did I get the right button? Yes. So remember to fill out the survey. And if you have any further questions, feel free to stop by up here and talk to me.